Thank you very much. Teams continue to monitor here at the mission with everything on track for successful launch. 2024 has been a near year of important. NASA's 31st resupply mission to the International Space Station this year marks the end of the deorbiting laboratory. This shows what is possible and what can be built on dedication and hard work. Let's take a closer look at how the teamwork has kept the station going all year. The year started with Progress 87 bringing important supplies to the international space. NASA's SpaceX 2949th resupply mission came after a critical station. Research and hardware ensuring support aboard the orbiting laboratory. Axiom Mission 3 expanded the research capabilities, introducing new perspectives from around the world. In March, Crew 8 launched from Florida. Each crew's transition mirrors the importance of coordination and teamwork to maintain station operations. As the year progressed, NASA's 30th resupply. The arrival of the extra crew on board the Soyuz MS-25 and the mission with SpaceX kept the flow of research, resources, and explorers going. Progress keeps the new momentum going. As summer comes, Boeing's crew flight test marbles the key milestone in human spaceflight and the NG-21. The mission brought supplies to daily life's research. The arrival of Soyuz MS-26 made things even longer. Duration of human spaceflight. With the crew's arrival, the station is still a center for progress and global cooperation with a place where people go to explore. People from all over the world work together to learn more about life in space and make opportunities for the future. Space exploration is a shared goal. The commitment and flexibility of many people on Earth and in space work together to keep the station running. As we look to the future, we are still focused on building a future for exploration that pushes the limits for all of humanity. It is clear that the teamwork of many people around the world has made it possible for the milestone to happen on the International Space Station. The journey doesn't stop there. This mission is set to deliver more than 3 tons of important cargo, such as scientific hardware and samples that will help the microgravity environment of the space station gives scientists a unique chance to study physical and biological phenomena that can lead to new technologies for exploring deep space and make life better on Earth. Engineers have spent months or even years getting ready for this moment. Let's look at some of the science. Going to the station. NASA and its international partners are starting scientific research on SpaceX's 31st commercial resupply mission to the International Space Station. Look at solar wind and make a data set to test adult theories about solar wind, which is 1. Arctic moss, which is 1,000,000 degrees hotter than the sun, will be studied to see how it affects plants. Results could help find biological systems that can be used in life support systems on future missions. Dozens of samples will be exposed to space to test them and help. Resents better understands the impacts of spaceflight results could support better design for spacecraft and salt lights. Researchers will show how to test the integrity of samples. Could help with the creation of methods for fixing the inside of spacecraft. And improve applications on Earth. Discover more about all of the science making the journey to the orbiting lab at NASA. gov/ISS. Science. IT is T-51:00. And everything is still going for launch. The transporter erector, or strongback or TE Falcon DT, is the big truss structure you can see from. You heard that call out. Countdown to terminal. For strongback retract and Dragon, go to configure for terminal count. Dragon in terminal count. Eternal power. The ring that is calling out for Dragon. Transitioning to eternal power and ahead of the erector reclining. You can see the clamp arms below Dragon start to open. Now the transporter erector is designed to support Falcon 959, the launch pad, and using umbilicals or flexible lines, thought the vehicle as fluids power and telemetry from ground systems to the rock kettle in payload until Falcon power. From you can see the clamp arms beginning to, at the top of the second stage, open under the Dragon. You should see the structure on the right. Final check. MD go for launch. You see reclining from Falcon. You see reclining from Falcon. There it is, fully reclined from Falcon-9D. We have a backup chance tomorrow at 8:06 p.m. time in the middle. 9:06 a.m. Eastern. At this point in the thought countdown, the first and second stages are almost fully loaded with almost 1 million pounds. Falcon 9 will be in the startup. This means that the rocket can do things on its own. The launch countdown is now being run by night computers. The engines will start up just 2 seconds before T-2 seconds. The Falcon 9 team is keeping an eye on things. The weather is good, and the range is ready to support the launch at 9:29 p.m. time in the east. And the weather is good, then the last few minutes Falcon 9 is doing its final house checks on the main communications avionics ahead of launch. Stage 2 is finished, called the engine or the wiggle test, and when SpaceX moves the nozzles. So little to make sure that the hardware is good for night. That is Dragon now moves to continue the checkouts for the first stage engines, and that happens just a few seconds before. At the time of launch, the International Space Station will be flying 260 statute miles across the Atlantic Ocean. Falcon 9 is starting up. Dragon is in countdown. Everything is ready for the launch of Falcon and the CRS-31 mission. 15 seconds. T-10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Task. And liftoff. Go SpaceX. Go Falcon. We have liftoff. NASA's SpaceX Resupply mission is on its way to the International Space Station. Station with science, supplies, and the spirit of discovery. The vehicle is moving both up and sideways during the ascent and now during this turn. Away from the launch pad. Telemetry is okay. Typically needs to go 17,500 miles per hour horizontally to stay in the air and not get pulled back down to Earth. You heard that call out and engines back in preparation for Mask X. Mask Q. There is a call out for Max Q, which is the maximum 𝐂𝐿𝐷IMIC pressure the vehicle can handle. We will see a few of these during the ascent and shortly after. Events happening in quick succession, beginning with the main engine cutoff. Then stage separation. Stage 2 engine chill. The second engine startup and the boost backburn of the first stage. You heard the call-out. For the second stage engine chill starting in preparation for that engine startup. We are 30 seconds away from the Merlin engine on the first stage. Will shut count. Shortly after that, the stage 1 and TRO will separate from each other. The engine on the second stage will be another and start. The second engine start is when we light the second stage's single Merlin vacuum engine will start up shortly after the first stage's boost backburn. There is a main engine cult off. Main engine cult off. Confirmed. Stage separation. Separation of stage. Applause. There you can see a beautiful view of the second stage engine start along with the start of the first stage boost backburn. And view interests the second stage engine there and the first stage. The first stage on the left is now in the middle of the boost back.